We will be exploring the energy cycle. This exploration will focus on three sources of energy: natural gas, solar, and wind, and their destinations, like heating your stove or charging your devices. First, let's take a look at one of CPS Energy's natural gas power plants. Click on the pipeline to harvest the natural gas. Natural gas comes from within the earth. It is extracted by drilling deep into the ground. It is then transmitted through wide pipelines from the gathering area to natural gas processing plants, then through more pipelines to be used as fuel for power plants. A natural gas power plant, such as this one, uses two turbines, one gas, one steam, to generate electrical energy. The combination of these two turbines makes it a combined cycle power plant, one of the most efficient and reliable power stations. Natural gas is burned inside a gas turbine. The gas turbine is massive. It weighs almost as much as a fully loaded commercial passenger aircraft. Compressed air goes into the gas turbine and is mixed with fuel. The fuel is ignited, and the compressed air and fuel mixture spins the blades of the turbine as it moves through them. A connected generator converts the spinning energy into electricity using magnets. Leftover heat from the air and natural gas mix are caught by a heat recovery steam generator, or HRSG. The HRSG is a boiler with many tubes containing water. When the excess heat from the gas turbine passes over the tubes, the water boils and turns into steam. The steam from the HRSG is connected to the steam turbine through pipes. The pipes are full of pressurized water vapor. When the steam flows through the steam turbine, it spins the turbine's blades. The mechanical energy of the spinning blades is transformed into electrical energy through the generator, just like the gas turbine does. The generator transforms the mechanical energy from the combined gas turbine and steam turbine cycles into electrical energy. It does this by harvesting the electrical energy with magnets and coils. The magnets and the rotation of the coils excites and moves the electrons, creating an electrical flow directed to a transformer. The moving electrons are the electrical energy. Law of conservation of energy. Energy cannot be created or destroyed, only changed from one form to another. In this example, the chemical energy in the form of natural gas is converted through combustion to mechanical energy by the turbine blades and waste heat. The waste heat energy is captured to create more mechanical energy through a steam turbine. The generators convert the mechanical energy to electrical energy. Find and click the solar panel. Solar panel farms are in central Texas. They transform energy from the sun into electricity using something called the photovoltaic effect. Solar panels are photovoltaic systems made of solar cells. The cells use photons from sunlight to create an electric current. This electrifying event is called the photovoltaic effect. To connect solar panels to the grid, we use a direct current, or DC, to alternating current, or AC, inverter. 7.4% of San Antonio gets power from solar farms. The harvested energy is transformed to a higher voltage in the transformer and sent as far as hundreds of miles to be used by you. Find and click the wind turbine. Wind farms are also scattered all across Texas. Wind is created by the uneven heating of the Earth's surface. Wind speed, air density, and blade radius are the factors of energy output of a wind turbine. Steady winds are more efficient than high winds, even though higher winds create higher power. Wind turbines only work within a certain range of wind speed. 14.5% of San Antonio gets its energy from wind power. Like the solar panels, wind turbines send harvested energy to a transformer to prepare it for the long journey ahead. Click on the Up Substation. Electric power from the power generating station flows to the substation. The substation is where the power is transformed to the correct voltage for transmission. The great thing about AC or alternating current electricity is that its voltage can be stepped up or down. This is similar to a high-speed train going maximum speed between cities, then slowing down to pick up and drop off passengers. The voltage is stepped way up to more efficiently pass through the transmission system, then the voltage is stepped down for use by businesses and residences. Click on a transmission tower. Transmission wires act like a road for the electricity, guiding it to your home or business. Transmission conductors are copper or aluminum. Wires sag and tighten depending on the current load running through them. Click on the step-down substation. Step-down substations reduce the high voltage power from the transmission system down to lower voltage to run on overhead or underground power lines through the community. The electricity on the utility poles is much higher than we use in a business or a residence. Distribution lines are where the electricity is delivered for industrial, commercial, or residential customers. Click on the highlighted tree. When a live wire is down, a protective device, such as a fuse or circuit breaker, attempts to cut off the electricity and make it safe. However, you should never touch or go near downed power lines. Live wires are extremely dangerous. You should treat all wires as if they are live and have electricity flowing through them. If you see a power line down or damaged, stay away and notify CPS Energy immediately. When trees or other events cause downed power lines, our trained crews will safely repair the damage and restore power. Click on the electrical pole with the transformer on it. Distribution transformers reduce the voltage so electricity can safely travel through smaller secondary or service lines to commercial and residential customers. The electricity goes through one final transformer to reduce the voltage before it goes to your home or business. It is then passed through a meter to measure how much energy is being used. This is how CPS Energy knows how much to charge on a bill. Advanced meters with communication technology embedded can also detect and report outages back to the utility. The lights turn on, the stove heats up, and you can charge your devices because the electricity is releasing the energy it carries. Thanks for participating in Electrifying San Antonio, powered by CPS Energy.